Hi everyone. So this is the second part of CPET Physics 2022 solution, and in this solution we will discuss some questions from the classical mechanics. So the question number 8 says that if the Lagrangian does not depend upon the time explicitly, then what happens? Okay. So this is very important concept. So actually, what a concept the Lagrangian term, we know that this is equals to sum over of pk qk dot, okay, minus the Hamiltonian h. Okay. So ଯେତେବେଳେ ପିଲାମାନେ ଜାକୋବିସ୍ ଇଣ୍ଟିଗ୍ରାଲ ଆମେ ପଢ଼ିବା ଓକେ ତ ଜାକୋବିସ୍ ଇଣ୍ଟିଗ୍ରାଲରେ ସେଠି ଗୋଟେ ଇକ୍ୱେସନ୍ ଅଛି ପିଲାମାନେ ମନେ ରହିଥାଉ d upon dt of okay sum over of p k q k dot minus the Lagrangian L, this equals to minus del L upon del t. Here del L upon del t, that means the partial derivative of Lagrangian, and we know this quantity is equals to the Hamiltonian, that is s. So we can write this as dh upon dt, this equals to minus del L upon del t. Okay, so according to question, if the Lagrangian does not depend upon time explicitly, that means the whole of the quantity this one, okay, whole of the quantity this one should be tends to 0. That means ds by dt, sorry, this one is dt, okay, this portion is only dt, okay, this is dt. So dh upon of dt will tends to 0. If this portion tends to 0, that means we know that h is a constant. Okay, so actually h is a constant, or we call this is a conserved quantity. So ପିଲାମାନେ ଗୋଟିଏ ଜିନିଷ ମନେ ରହିଥାଉ, in any Lagrangian, okay, in any kind of Lagrangian, if that Lagrangian does not depend upon any quantity, okay, it may be time, it may be position explicitly, then we will get two results. Okay, ଏଠି ପିଲାମାନେ ମୁଁ ଇରେଜ୍ କରିଦେଉଛି, ତ ମନେ ରହିଥାଉ କ'ଣ କ'ଣ ପିଲାମାନେ ରିଜନ୍ ହେଇପାରେ. The first case is if the Lagrangian L is independent of position coordinate, that is qk dot, okay, then the corresponding momentum, that is pk, is here constant. Okay, this is called the conjugate momentum. Again, if the Lagrangian does not contain time, okay, that means it is independent of time explicitly, then the corresponding Hamiltonian is always constant. So these two theories are very important, and you will find this in Jacobi's integral. Next, come to the question number 9. So the question number 9 also from that Lagrangian. The question is given by the generalized momentum px of a particle of mass m, velocity vx in an electromagnetic field with charge q, and x component of vector potential is x. Okay, so actually Lagrangian, whenever charge particle is inside an electromagnetic field, what will be the corresponding momentum of that particle? So we have to find out the Lagrangian for a charged particle in an electromagnetic field. The value of the Lagrangian, this equals to L equals to the kinetic energy term, that is half mx dot square, okay, minus q into phi is a scalar potential, plus q into vx, that is velocity of the charged particle in x-axis, dot ax, and ax is called the vector potential. Okay, so here we know that del L upon del x dot, this equals to px. Okay, so we have to just find out the derivative with respect to x dot. तो पिलाମାନେ ଏଠି ଯେତେବେଳେ ଆମେ ଡେରିଭେଟିଭ୍ ଫାଇଣ୍ଡ ଆଉଟ୍ କରିବା କ'ଣ ଆସିବ, this portion reduces to mx dot, clear. Again this portion goes down to 0. Again from this portion we know that vx, that means this is actually x dot. Okay, so here the answer will be plus qax. So mx dot plus qax will be the answer. So from this question, option number 4, okay, option number D will be the correct answer. mvx dot plus qax. Now come to question number 10. It is given by the moment of inertia of about a tangent in the plane of a circular ring. Okay, so moment of inertia of a circular ring about a tangent. Okay, circular ring about a tangent. The simple pilamane, this is a circular ring. Okay, this is the center about which the axis of this ring passes, and this is the tangent of that circle. So it is the moment of inertia I way. Okay, and here the moment of inertia is ig, that is about its center. So according to the parallel axis theorem, parallel axis theorem, it says that the total angular momentum, the total moment of inertia should be equals to ig, that is moment of inertia about its diameter, plus half m r square, where m is the mass of that circular ring and r is the radius or the distance of the tangent from the center or from the axis of that circular ring. Okay, so in this case the moment of inertia of the circular ring about its axis, okay, this is equals to half mr square. Sorry students, actually this one will be not half, this one will be only mr square. Okay, apology for the mistake. So now the solution will be half mr square plus mr square. Clear? So this equals to 3 by 2 mr square. So according to this, the answer will be option number B. Now the next question is, the elastic potential energy of a stretched wire is given by this. Actually here गोटे क्वेश्चन पे रंग अच्छी, आई मीन बहुत इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी मन रही पे इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी सॉरी इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी डेंसिटी. ओके, पोटेंशियल एनर्जी डेंसिटी दैट इज U, दिस इक्वल्स टू हाफ इंटू स्ट्रेस multiply strain. This is the actual answer. Okay, this is the formula for electrostatic potential energy density, that is energy density. And here it says about the potential energy. That means if we find out the potential energy per volume is called the potential energy density. But here the potential energy as पचारछि पिलाने. So एटी आंसर कोन आछियो ना, potential energy is equals to half into stress into strain multiply the volume part. But here option रे किछि भी सेमति किछि नाही. I think there may be some wrong. So it is the potential energy density पचारता, ताले the answer will be option number B. तो पिला माने एठी 11 नंबर को टिके मार्क करथाओ, किछि जदि wrong होइता then comment box रे please inform करो. Then come to the question number 12. The question number 12 is given by the Lagrangian of a simple pendulum is given by these modes. Okay, the Lagrangian is given by L equals to half ml square theta dot square minus mgl multiply 1 minus cos theta and choose the wrong expression. मन रहता wrong expression कोटा हमें choose करिया. तो केमति choose करिया? तो first देखो पिला माने we know that del L okay by del theta dot this equals to p theta. Clear? तो एक केसेस रो पिला माने जस्ट with respect to theta dot रे तमे derivation find out करो, we will get that m l square theta dot this equals to p theta, जोटा कि ऑप्शन नंबर 1 ठीक अछि. Then goes to the option number 2. Option number B रे पिला माने कोन कहछि p theta dot. So for p theta dot what is the formula? p theta dot equals to del L upon del theta. Okay, तो एठी पिला माने del L upon del theta जेतला हम फाइंड आउट करिया, आंसर कोन आसियो ना mgl. Okay, mgl and cos theta रो डेरिवेटिव होछि minus sin theta. So minus mgl sin theta will be the answer. But here the answer is m by gl sin theta. So this is the wrong option. फिर भी पिला माने हम ऑप्शन सी को चेक कर दवा if there is any wrong. तो मन रहता ऑप्शन सी चेक करिया भाई हम सिंपल कोन करिया ना Lagrangian इक्वेशन ऑफ मोशन एठी हम यूज करिया. कोन Lagrangian इक्वेशन मोशन ना d upon dt of del L by del theta dot okay minus del L by del theta this would be is equals to 0. तो पिला माने देखो एठी del L upon del theta हमें फाइंड आउट करते केते आछि पिला माने m l square theta dot. Okay, again आरो डेरिवेटिव हमें फाइंड आउट करिया कोन आसियो ना दिस टर्म रो डेरिवेटिव केते आसियो ना थीटा डॉट रो विथ रिस्पेक्ट टू हमें डेरिवेटिव फाइंड आउट करिया. तो कोन आसियो ना m l square आसियो. ओके, नाउ sorry m l square again theta dot रो डेरिवेटिव विथ रिस्पेक्ट टू t, दैट मींस थीटा डबल डॉट माइनस del L upon del theta पिला माने ऑलरेडी एती वैल्यू हमें फाइंड आउट करछे, दैट इज माइनस माइनस प्लस m g l sin theta is equals to 0. तो पिला माने देखो ए टर्म को जेतोले हमें कैंसिल करबा ऑलरेडी कॉमन टर्म रे m एंड गोटे सिंगल l एटी कॉमन आसे. तो रहिला टर्म कोन ना l थीटा डबल डॉट प्लस g sin theta this equals to 0. So option C also correct. Again पिला माने देखो से बचारछि 1 upon theta dot del L by del theta किता आसे. तो पिला माने एठी चेक करो del L upon del theta dot रा हमें वैल्यू फाइंड आउट करछे. तो केते आसला m l square theta dot. Okay, तो 1 by theta dot that means if we find 1 upon theta dot then theta dot को पहले हम डिवाइड कर दियो, आंसर केते आसे रे m l square. एठी ऑलरेडी m l square अछि, तो ऑप्शन डी आल्सो करेक्ट. तो एठी रॉन्ग स्टेटमेंट होछि ऑप्शन नंबर बी व्हिच इज द आंसर फॉर दिस क्वेश्चन. Is given by the Lagrangian of a free particle in the spherical polar coordinate system. Okay, so in spherical polar coordinate system the Lagrangian is given by this much, L equals to half m r dot square plus r square theta dot square, which indicates that means एठी हम पिला माने cyclic coordinate एठी हम कोटा हमें फाइंड आउट करियो. त मन रहितो एनी काइंड ऑफ Lagrangian coordinate सिस्टम रे जदी Lagrangian रो एक्सप्रेशन रे जो टर्म एब्सेंट होछि दैट टर्म इज कॉल्ड द cyclic coordinate. Okay, that means if any term does not appear or disappear in a Lagrangian term, एठी पिला माने देखो एठी r डॉट टर्म अच्छी, दैट मीन्स थीटा डॉट टर्म. ओके, पोजिशन कोऑर्डिनेट अच्छी, एगेन आर टर्म भी अच्छी, एगेन चेक करो थीटा डॉट भी अच्छी. बट ये देखो थीटा रो किसी term nahi, that means here theta is the cyclic coordinate. So here option C is correct, that is theta is cyclic coordinate. Okay, so theta is a cyclic coordinate, that means the corresponding conjugate momentum, that is p theta, is not conserved here. Okay, actually this is the conserved quantity हेबा कथा, जेहेतु थीटा साइक्लिक कोऑर्डिनेट तो तार करस्पॉन्डिंग कौन आसे मोमेंटम ना पी थीटा, दिस इज द कॉल कंजुगेट मोमेंटम एंड दिस शुड बी ए कंजर्व क्वांटिटी, जेमती आम ऑलरेडी क्वेश्चन नंबर 8 डिस्कस करते लाग्रेंज एंट्री जो टर्म पे आबसेंट थी, सपोज फॉर थीटा टर्म आबसेंट, तार करस्पॉन्डिंग पी थीटा हूँ कौन कांस्टेंट, इफ द टी टर्म आबसेंट देन द करस्पॉन्डिंग हैमिल्टोनियन इज कांस्टेंट इन मोशन. ओके, सो दिस इज अबाउट क्वेश्चन नंबर 13. So answer is option C. Again come to the question number 14, plan at a direct answer. So question number 14 answer कौन होगा पिला माने ना, answer will be option number C. That means for the position coordinate qx equals to del h upon del pk, but for momentum coordinate px dot equals to minus del h upon del qk. So this will be the correct answer. So this is all about the questions from classical mechanics. Thank you.